students, good afternoon. Today we will discuss one more periodic property, that is electronegativity, which is very important for us. Electronegativity means it's a tendency of an atom to attract electron pair towards itself. That is called electronegativity. Okay. So electronegativity values also there for some atoms, not for some atoms, for maximum of atoms we can understand and we can easily remember also. That I will give you easily how to remember later on. But first of all, what is electronegativity and what is electron gain enthalpy? See, electron gain enthalpy means the amount of energy released when electron added to neutral isolated gaseous state atom. Correct? So that is a quantity. Electron gain enthalpy is a quantity, amount of energy which is released. Or second electron gain enthalpy means amount of energy required to add second electron for uni-negative ion. Correct. So electron gain enthalpy means some quantity that has some units, energy units like kilojoules, kilocalories. Okay, like that you have some units, electron volts, like that. But electronegativity has no units for a particular atom. Electronegativity values we will consider, that's it. And electronegativity, to find, we have some scales. Got it? So everything we have a particular number, I mean for every atom we have a particular number, electronegativity number we have. So those we will discuss with a simple trick I will give you. But first of all, electronegativity has no units because it is just character, attracting character. Okay, like ice cream. Ice cream has a character to attract. Okay, some jewelry, attract. Okay, dress, attractive tendency. That's not a quantity, it's a character. Okay, mobile, it's attracting. Mobile has attracting tendency. You see that mobile, oh what a nice mobile it is. Car, bike, like that. So these all are what? Characteristics, tendencies. So for atoms, those are the attracting tendency. Those attracting tendencies are called electronegativities for individual atoms. So electronegativity means the tendency of an atom to attract electron pair towards itself is called electronegativity. So electronegativity when exists? When that is in bonding. So electronegativity, how we will say? Attracting tendency I am telling. So electronegativity is inversely proportional to atomic radius, because that have to attract the electron pair. Some atom X and Y atoms are there. Atomic radius of X is less than Y. Understand? Or greater than X has a smaller size. Okay, like that. Whatever here. Okay, X has less atomic radius than Y. That means who is more? Some bond is there between X and Y. Then this bond, electrons. Bond means two electrons. Do you know that? One line, one sleeping line like this. Horizontal line indicates what's the bond, on covalent bond. In chemical bonding we will discuss. Simply remember, one line or one bond means two electrons, one pair otherwise. Okay, so this X and Y between one pair is there. One pair. What these two dots? Two electrons. So these two electrons will attract towards X. Why? Why means WHY, not this Y. Okay, why these bonded electrons attract towards X? Because X has a small size. So simple no exceptional cases here. Okay, who have small size, that will be a more electronegative atom. That's it. Okay, and who have nearest noble gas configuration, like only one electron required, they have small size, like fluorine, chlorine, bromine, iodine. If you see who is more electronegative, means fluorine. See, the most electronegative atom is, do you know who is the most electronegative atom? Most electronegative atom is fluorine. Fluorine is most electronegative atom. Size is small. Electronegativity is inversely proportional to atomic radius. If atomic radius is small, attracting tendency is more. So there is a bond between X and Y. So X is more electronegative. So bonded electron is moving towards X. Okay. Next, some H and F. Fluorine is most electronegative, I said. Hydrogen, even small, it has one electron, so it can easily lose actually. So electronegativity is more for fluorine. HF, hydrogen fluoride, this is hydrofluoric acid otherwise. HCl. Chlorine is more electronegative. Certainly, when a bond is present between these two atoms, they will move towards chlorine. Here, this bond move towards fluorine. Not completely, partial displacement. Partial displacement, HF. So partially fluorine has minus, partially hydrogen has plus. This pair shared by both, but this pair slightly displaced towards fluorine. Okay, I'll give you one example actually. Chocolate shared by two persons. One is my daughter and my son. Who is more electronegative? My son, suppose. He is small, that's why. So, they have to share that chocolate 50%, 50%. So, one chocolate if I was given, okay, so 50%, 50% they have to share. So, Kit Kat, my favorite chocolate. So, they have to share equally actually. But he was taken somewhat extra. Means he taken one 2/3. This my daughter taken just 1/3 only. So sad. So who is more electronegative? That taking somewhat extra. Both are sharing actually. Both are eating that chocolate. Like that. Both are sharing this electron pair, hydrogen and fluorine. But who is taking more means sorry. Fluorine taking more actually. Okay. So these are about electronegativity values. Sorry, electronegativity, how to identify. Okay, so electronegativity, who have more means fluorine have more. Okay, group with electronegativities like that we cannot say, because fluorine, so just I will give electronegativity values. Fluorine electronegativity value is 4 and oxygen is 3.5, then chlorine is 3. That means we cannot say halogens have highest electronegativities, because only fluorine after the second most electronegative atom is oxygen. Who is the second most electronegative atom? Oxygen. How to remember those electronegativity values? I will tell you. These are the values actually. Highest electronegativity value means 4 only. How to have those electronegativity values means we have electronegativity scales like Pauling scale, Mulliken scale, like that. We will discuss about those right now. Understood? So those are very important. Let's see one by one. Electronegativity scales. Okay? Electronegativity scales actually. So before only written, just to avoid time wasting. So Pauling scale, actually Pauling is a scientist. Pauling is a scientist. He was given electronegativity values differences. Here I will give you very clearly. XA means electronegativity of atom A. Okay. XB means electronegativity of atom B actually. Okay. So AA plus BB when react combines together, AA and BB combines together, and 2AB you are having. Okay. So AA has bond energy of AA and BB has bond energy. BE means bond energy of BB and AB has bond energy of AB. Bond energy means the amount of energy released when the bond formed between A and B. Okay, I repeat, bond energy means energy released when the new bond formed between this A and B. Otherwise, the amount of energy required to break the bond. Okay, after formation, amount of energy will release because bond formation means stability will come. Once stability came, energy decrease. Energy and stability inversely proportional. Understanding? So bond energy means the amount of energy released when bond formed. Otherwise, the same amount of energy required to break the bond. Okay. So what here Pauling was given? Pauling was given electronegativity differences actually. Electronegativity differences XA minus XB. Actually, who will be first we will write means who is more electronegative. So here A is, suppose if A is more electronegative than whom B, then XA minus XB we will take. If B is more electronegative, sir, then XB minus XA we will write. Understanding? But these bond energies remain same. So what is the formula he was given? So he was given this formula. Please remember everyone. So sir, you said electronegativity don't have values. These kilocalories and kilojoules are not units for electronegativity. Remember, these kilocalories are the units of these bond energies. If the bond energies are in, these bond energies are in kilocalories, then he was given formula XA minus XB is equals to 0.208 root delta kilocalories. This formula he was derived and given, and we have no need to bother about how that formula came. Oh my god, no need of worry. Okay, just simply remember XA minus XB is equals to 0.208 root delta kilocalories. What is delta? Bond energy differences. Because this is 2 moles, bond energies of products minus reactants. Actually, if you take 1 mole, what you will take if you want to take 1 mole? This will be 1 and this will be half and this will be half. Right? So for 1 mole, delta is bond energy of AB minus half into bond energy of AA and bond energy of BB here I was taken. That is delta. What is delta understood? Delta is bond energy of AB minus half into bond energy of AA plus bond energy of BB. Very important. Understood, sir, everyone? Bond energy of AB is product. So simply products bond energies minus reactants bond energy, delta. What is delta? Here you can write delta is energy of products minus energy of reactants. What energy? Bond energy. Product. AB is a product or not? Yes. So between AB, who is more electronegative? A is more electronegative. We are considering. So XA minus XB, that's why we written. Understood, sir? So here clearly I written XA minus XB, he was given Pauling that XA minus XB is equals to 0.208 root delta kilocalories, and where delta is bond energy of AB minus means products bond energy minus reactant bond energy. We taken half by understood here. So here if it is 1 mole forming, so half mole and half mole have to react. Understand? If you multiply with 2, 1 and here 2, that's it. If you want to take here 2 moles and here 1 mole, you can take. That's it, no problem. So both are same. So here what I said, bond energies are in kilocalories. Then this formula to have differences. Okay, XA minus XB. Understood? So, and if the bond energies, if this delta is in kilojoules, then XA minus XB is equals to 0.1017 root delta kilojoules. 208 kilocalories, 0.1017 kilojoules. That's it. Okay, so please remember these two formulas. We will use these formulas for solving numericals also. And he was taken the reference atom. Electronegativity of hydrogen is 2.1. This is the reference electronegativity atom. Who is the reference electronegativity atom? Hydrogen is the reference electronegativity atom. Hydrogen electronegativity, he was considered 2.1. Okay, that was also derived actually. Reference electronegativity atom is hydrogen. Hydrogen electronegativity value is 2.1. And suppose chlorine you want, so HCl we have to take. Understand? So like that we have to consider this Pauling scale. Pauling scale means what? Xa electronegativity differences was given, Xa minus Xd was given, 0.208 into root delta. Okay, suppose by giving this hydrogen electronegativity, suppose they are asking chlorine. Okay, how to find? Let's see. Okay, sir. So write down all these things, have a screenshot. I'll tell you one example so that you can understand. Who is the reference electronegativity? Hydrogen. How much? 2.1 hydrogen electronegativity value. Okay, so please remember all those things. Next, I'll give you one example. Let's see. What is electronegativity of chlorine? Okay, if electronegativity of hydrogen is 2.1, they won't give actually, but I am giving in this numerical, in this example. Okay, example. And if bond energy of HH, bond energy of HH is 80 and bond energy of Cl is some 50 and bond energy of HCl is 100. This is given. Then what to do? Very simple. So this is given in kilocalories. This one 100 kilocalories given. Then what you will take? Energy, bond energy. So I told you already. So chlorine, when from left to right size decreases. So electronegativity of chlorine is more than electronegativity of hydrogen. Whether it is correct or not, from this example we can understand. Let's see. I will take electronegativity of Cl minus electronegativity of hydrogen is equals to 0.20. Okay, something 0.2 you take. Okay, 208 something. 0.2 into root delta I was given in kilocalories. So what is delta now? Delta is equals to energy of HCl, because HH plus ClCl gives rise to 2HCl, right? Correct or not? Correct or not? So bond energy means per mole only actually. Bond energy means per mole. So what to do? So you have to take for 1 mole and this is half and this is half. So bond energy of HCl minus half into energy of HH minus energy of ClCl. Understood what I written there? Okay, delta I am finding here. How I am finding? By taking half HH and half ClCl gives rise to HCl. Because bond energy means per mole. Per mole means you know Avogadro number of atoms. So that is unnecessary. Per mole means 1 here. So delta is equals to, I am writing once again, energy of HCl minus half into energy of HH plus energy of ClCl. Okay. So energy of HH is 100. Delta I am writing. Understand? So minus half into, it's a 80 plus 50. Okay, 130 by 2. So delta you will have. That delta if you substitute here, and in this HCl minus hydrogen 2.1, so 0.2 root delta. This delta substitute here, you can find answer. So this is about the Pauling scale. So next Mulliken scale we will discuss. Okay, and then how electronegativity we will find. I will give you one trick. Then valency and oxidation states. Only two, and acidic character and basic character. Three topics we will have, and then we will enter into chemical bonding. Okay sir, thank you very much, and please note it down all these things and find out answer here. Okay, how much you are getting. So 100 minus half into 80 plus 50, and no need actually all these things. If they are asking also, I will say. If they said X, I cannot say, but chlorine electronegativity value is 3. How to find? I will give you one trick for you later on. Okay, thank you.